now we sort of want to go over the hardware, uh, the Arduino hardware that you guys are going to be using. So I hope that everyone has received their Arduinos. We shipped those out, and I believe all of them have been delivered, so everybody should have them. If not, please have your instructors contact me so we can figure out what the issue is. But we're going to cover, basically the hardware of the Arduino, the pins, how is this thing laid out? So this is what the Arduino, specifically the Arduino Mega 2560 that we're going to be using for this course. It is a microcontroller development board that's designed sort of for hobbyists and people just getting into microcontroller programming, right? Arduino has its own coding interface. An IDE is an interactive development environment, and that allows you to write, upload, and troubleshoot your code. There's a lot of good tutorials and a fairly active forum for Arduino that will help you, if you run into issues programming. So, like I said, it's a microcontroller development board. But what's a microcontroller? Well, it's an integrated circuit that is basically an entire computer, right? It has a processor. It can receive and send input. It's got memory to store information. It can do operations on that information. It has input and output pins, so it can do communications and manipulation of external devices. A development board is basically a PCB, which we should all be familiar with now, that provides you with some easy interface to that microcontroller, right? So if you go back and look at this center piece here is the actual microcontroller, right? But that's a very tiny chip that is a surface mount chip with many, many pins, and that's very difficult to do any sort of prototyping and development on, right? You can see how, like, once I've fully figured out what I want to do with it, I could design a board and have that chip soldered on there, right? But I want something that can help me do that development, and that's what the development board is for. It gives you, hardware for connecting devices like USB ports or other pins, integrated circuits. It provides you a way to access the manipulation that microcontroller can do. So it's going to give you the basic inputs, outputs for programming and interacting with the device. So it's useful for, small basic projects. Obviously, if you were developing a mass-produced device, you wouldn't want to use like an entire Arduino development board, right? You would design your own board and install the microcontroller itself on it. So there's actually a whole bunch of Arduino boards. We're using the Mega here. There's this real small one called a Nano and a Teensy. These are all both very small. There's also an Uno, which is a very common Arduino board. There's a whole family of Arduino boards. We're just using this particular one because it has good capabilities for what we want to do. Arduino is not the only name in the game when it comes to these things. One thing you may have heard of is a Raspberry Pi. That's sort of a bigger, more of an entire computer on a single board, but it is a microcontroller development board. There is another set of boards called Beagle Bones. And then, there's something called the basic stamp, which is actually what was historically used in this course before we switched to the Arduino. But the whole point is that there's a whole variety of development boards that you could use if you're trying to do some tasks. So here are the major specs for the Arduino that we're going to use, which I said is the 2560. So the actual microcontroller, this chip in the center here, is the AT Mega 2560, right? That microcontroller operates on 5-volt logic. The actual input you can give to the Arduino via this barrel plug, or the VIN pin is 7 to 12 volts. Well, is the recommended, but it'll actually take 6 to 20. You have 54 I/O pins out on these headers. Input output pins. I was asked what are I/O pins, and they actually have a few different functions. 15 of these specifically, and you might be able to read it here, will provide what's called pulse width modulation. That's something we'll get to when we get to digital I/O. There are 16 of these pins that are analog input pins as well. So they can read analog voltage values on those pins. There is a limit to how much current can be supplied out of each pin. So 20 milliamps. If you supply more, you will damage the pin. There's also a 3.3 volt supply and a 5 volt supply here. And the 3.3 volt has a pretty small limit. There is also basically 3 types of memory storage on this board, and they're used for different things. There's the flash memory, which has the bootloader, so that has the actual OS, if you want to think of it that way, operating system. There's the actual SRAM, which is where your memory, all your program variables are stored. And you have a small EEPROM, which is what could be used for some non-volatile storage. If you had some emergency stuff, you were like, oh, I need to keep this one variable if I lose power. This entire thing runs on a 16 megahertz clock. It's got a bunch of built-in LEDs, and it's, you all can see how big it is and how heavy it weighs, but in case you're curious. So there are 2 basic ways of powering the Arduino. You can plug it in if you connect a USB cable to it, that'll power it. It also has a barrel jack, little round plug there that you can supply voltage. Recommended voltage 7 to 12. There is also a specific pin where you can supply voltage to VIN. And then it has a few power pins. Like we said, there's a 5 volt pin and a 3.3 volt pin. All of the I/O pins of the Arduino are going to operate on a 0 to 5 volt scale. That 3.3 volt is mainly because that's a common logic level, and there's a lot of circuits that are going to want 3.3 volt. So, like I said, here's the memory. You have the flash memory, And that's where your actual code gets stored on the Arduino when you upload it. You have the RAM, the SRAM. That's where all of your variables while the code is running gets stored. But that all goes away every time the Arduino is powered, loses power. And then there is a very small, what's called electrically erasable programmable read-only memory, or an EEPROM. And that is basically a very limited, like non-volatile storage where you could, store information, emergency, if you wanted to. We are going to mainly use an external SD card for our data storage, right? So we're not going to actually use the EEPROM in this course. So how do you talk to this thing? Well, usually you interface through the stackable header, and this particular footprint is Arduino has standardized across their boards, and they're standardized across a bunch of accessory boards called shields. So you have power pins, you have analog to digital pins, you have, like I said, digital I/O pins, and there's a number of serial communication on specific pins here. So like I said, we have these 16 pins right here. That's where we can basically read in an analog voltage. So if I have some voltage between 0 and 5 volts, I can convert that to a digital number. And so I'll use that for like reading the outputs of sensors that have a continuous variable. And then once I read those values into memory, I can then do other stuff with them. I've got these digital pins. These are going to be basically 0, 1, on, off digital communications. I can use that to manipulate external circuits. I can flash LEDs. Like I said, there are a certain number of these that have a few more advanced hardware capability. Pulse width modulation is something we'll talk about later. And interrupts are something we'll also talk about later. But interrupts basically let you interrupt the normal flow of circuit of your programming to react to a change on one of those pins. So you can see that might be pretty useful. So there's a few different pins that are dedicated to certain communication protocols. So there are what we call serial pins, also known as UART. This is going to be pairs of transmit and receive pins. So this is one like what your USB uses. That's how it talks to the Arduino, but there's actually four sets of those. There are pins for what is called the SPI protocol, and that has 4 different pins needed for that communication, and we'll get into this. There is also a set of pins for what's called the I2C or I2C protocol, and it's on those particular pins. We're all going to cover this all in detail. We'll get you, we'll work with each one of these, but just be aware that certain IO pins have dedicated, like, oh, these are the pins I can do SPI on, right? I can't necessarily do those communications on any arbitrary set of the digital pins. So sort of the most basic communication that we're going to first learn is the serial. That's going to use those 4 UARTs, right? And this is important because this is how you can talk back to your programming laptop with the Arduino. This is how you can have it output the value of variables. So it's done via this serial. So what you do is you call in your setup, you declare your serial with a particular baud rate. That's what this number is, this 9600. And it's important because on your laptop, you're going to have the serial monitor, and you need to match that baud rate to between the laptop and what you set in the program. And this particular, right, you see it has a serial with no number. That's also called serial 0. And that's going to actually go through TX0, RX0. But most importantly, that's going to get transmitted to the USB port of the Arduino. So that's going to be how you can actually live monitor what's going on the Arduino. We're going to use a lot of the serial. So on your actual laptop, you're going to open, as part of the IDE, the serial monitor, right? And this is just going to display whatever text got sent over the serial from the Arduino. So you can see right here, it's got a baud rate. So you want to make sure that matches whatever you set that in your code. And this is super useful because this allows you to, debug your code, see what it's doing live. Whereas with the other digital outputs, you're sort of limited into, hey, I'm blinking, or, this, you can send detailed information back. When you want to expand on the Arduino, you can use a shield. Shields are these, modular circuit boards that fit that footprint, and they give you basically standardized footprint where you can have increased functionality, right? Since you have this defined interface, you can have boards that fit that and interface with those pins. Specifically, we're going to use this GPS logger shield here. So this is going to have our SD card and our GPS unit on it. And then the thing that you're going to build as part of the base of your payload is the Megasat, which is also a shield, right? And that's what this big board underneath the Arduino is. So just some real common troubleshooting. Hey, I can't get my Arduino to do anything. Make sure you're supplying the right power. You want to make sure that it's connected, and you want to make sure that you've got the right libraries, keywords. You're plugged into the pins that you think you are. We're going to get into this a lot more when we actually start doing programming. There's some really good resources on the Arduino website. Arduino Playground has like just code examples, little mini projects that people have done. So it's a good place to look for if you're looking for ideas or troubleshooting. And then here's a whole bunch of useful references for all of this stuff. In particular, you want to be able to look at the Arduino specs and revs. And that is it for the Arduino hardware introduction.